Okay, so this is the relationship between differentiability and continuity. So this first one, they're asking you first to sketch it by putting it in your graphing calculator and drawing a sketch. So if you'll go ahead and do that, there are no exact terms, dots except for 2, 0 and negative 2, 0. So it basically looks kind of like this. It just says sketch, so you don't have to be very exact. But it looks basically like that. So it says based on the graph, I think that's supposed to say is f of x continuous at x equals 2 and explain your reasoning. Now remember, can we look at it and say it's not continuous? Of course we can. I mean, obviously you'd have to pick up your pencil and draw that so it's not continuous. But we want to use our three-part definition for continuity. So remember, the first thing is f of 2 has to be defined. So, because that's what they're asking us at 2, is this function continuous? So the first thing is f of 2, this is the first part of the definition of continuity. F of 2 equals 0, right here. On the graph, there is a solid dot, so it is defined. So the first part of the definition of continuity applies, it works. The second piece says that the limit from the left-hand side, as x approaches 2 from the left, has to equal the limit as x approaches 2 from the right. Well, looking at it, as I approach from the left, the limit doesn't even exist. So this doesn't work. So because of that, as far as the three-part definition, I can just write, that means the limit, the overall limit of f of x at 2 is d and e. It doesn't exist. So, therefore, f of x is not continuous. Which, of course, we said, by looking at the graph, you can tell it's not continuous. I draw this piece, have to pick up my pencil and draw this piece. But remember, looking at the graph is no longer good enough. You're now responsible for explaining why it's not continuous. Okay, so now the next question is find the value of the derivative at 2. So here's my function. And they want me to find the derivative. So first thing I'm going to do is write it as x squared minus 4 to the 1/2. That makes the derivative 1/2 the square root of x squared minus 4. Because remember the derivative, times 2, because we have to chain rule. Times 2x, because of chain rule. Let me work out chain rule real quick so you see. I'm going to say y equals u to the 1/2. U equals x squared minus 4. So dy du times du dx. That would be 1/2 u to the negative 1/2 times 2x. And then I plugged everything back in. That's where I got this. Okay, so that's my derivative. My 2's will cancel, so I'm just going to simplify my derivative. And I can write my x on top. Now they asked me to find it at 2. So let's plug 2 in. So I get 2 over the square root of 2 squared minus 4. Uh-oh. I know exactly what's going to happen. 4 minus 4 is 0. So this is undefined. So we can write f of x is not differentiable at x equals 2 because f prime of 2 is undefined. So that they ask you to justify yourself, this is what you would say. Alright, so now we're going to do the same thing again for 2 more functions. So I am going to turn off the recorder for a moment, let you try, plug them in your calculator to get your graph, then explain by the three-part definition of continuity if they are continuous, and then differentiate them and plug in the value and see what the derivative is at each spot. So then the next video will give the answers to these two.